Namaste everyone. Today I am going to discuss Laplace transform using Python. Before going to Python, let me go to a notebook where we can understand the Laplace transform first and then how to use the Python for performing Laplace transform that I will also discuss. So let us first take it the Laplace transform, and Laplace transform is Laplace of xt equal to integration minus infinite to infinite f of t, or if it is two-sided it will be minus infinite to infinite, so it will be minus infinite to infinite x of t e to the power minus st ds. When you perform this integration, after integration you will get the Laplace transform of the signal. For example, Laplace transform of e to the power minus at, if this is your signal, then you, after performing this integration, you will get 1 upon s plus a. Okay. Similarly, Laplace transform of, many Laplace transform pair. Laplace transform of 1h, 1 by s. Laplace transform of 1 of t is 1 by s square. Laplace transform of t square, and Laplace transform of whatever t square 1 upon s cube. Laplace transform of e to the power uh, omega sin omega t h. Laplace transform of sin omega t is how much? Just tell me what is the Laplace transform of sin omega t. Laplace transform of e to the power minus at 1 upon s plus l. Already I have written this. Laplace transform of t into e to the power minus at, that is 1 upon s plus a whole square. Laplace transform of 2 into your t square e to the power minus at is 2 upon, not right, equal here. It is not equal. These are the transform pairs actually. So 2 upon s plus a whole cube, and Laplace transform of sin omega t is omega upon omega square plus s square. Cos omega t s upon omega square plus s square. Laplace transform of 1 minus e to the power minus at a upon s, a plus s. Laplace transform of e to the power minus at sin omega t is omega upon omega square plus a plus s whole square. Laplace transform of e to the power minus at cos omega t, that is a plus s divided by omega square plus a plus s whole square. These are the different Laplace transform pairs, and our objective is to calculate Laplace transform using Python. So aim of this experiment is to calculate Laplace transform of various signals. Okay. So if you want to calculate Laplace transform is not like a simple FFT or numerical something. It is a algebraic transform. So we need some algebraic library before starting Laplace transform. And the solution for this algebraic library is SymPy. Similar to NumPy, there is one Python library known as SymPy. What is the advantage of SymPy? In SymPy, we have symbolic processing. In NumPy, we do numerical processing. Similar to that, in SymPy, we do symbolic processing. Means we can do the integration in symbolic form, differentiation in symbolic form, solving polynomials in symbolic form. So, like in algebra, we do everything in symbolic form. So, in the SymPy, we can perform operations by using the algebraic form only. Okay. So that is what is the advantage of SymPy. Let us uh, so how to get it? Just we have to write import SymPy. Similar to that, we write import NumPy instead of NumPy. If we need NumPy, you can import NumPy also with the same program. But for this symbolic processing, for the algebraic processing, we have to import SymPy. Okay. For making SymPy printable, I also write one more command called SymPy dot init underscore printing. If you are plotting, we will use the matplotlib as we were using previously, or we can use NumPy also. No problem. We will do Laplace transform by two methods. One is direct evaluation, another is by using the standard library. Okay. So I will explain you the one program that is already there. So I'm opening that. सर्विस से बोल रहे हैं हेलो प्रोग्राम मुकेश को हटाओ ना ऐसे क्यों करेगा एमएसएमई ऐसे कर दो ना तो लाइनें कम हो जाएंगी इसी तरीके से नहीं दो लाइनें तो भी जाएंगी ना ये यहाँ तक है ना तो ये तो खाली हो जाएगा ये लेबर और एमएसएमई एक लाइन में लिख दो काम कर देता हूँ उसको नहीं हटाना चाहिए Yeah, you can see the output here, e to the power minus 80 with here. Now we have to integrate it. Okay. Now we have integrated it 0 to infinite. I have integrated it from 0 to infinite. Okay, so up to pi, right? For augmented pi up to pi by 2 it is this, and 0 to infinite it is this one. Okay. Now again I have used the standard Laplace transform of SimPy library to calculate the Laplace transform of various signals. Okay, so here you can say that I'm writing import SimPy, then the SimPy init printing, and then import matplotlib pyplot as plt. After that, omega equal to SimPy dot symbol omega is coming here, and exp is also defined, sine is defined, cos is defined. Okay, so now I am defining a short form of Laplace transform so that we don't have to write the complete Laplace transform expression every time, because in this we can just write L of f. So then the SimPy Laplace transform is converted to this L of f. Okay, and inverse Laplace is also being defined like this. So SimPy inverse Laplace transform is getting converted to this one. Now take the functions together. I am taking 1, then t, then e to the power minus at, t e to the power minus at, t square e to the power minus at sin omega t, cos omega t, 1 minus e to the power minus at, e to the power minus at sin omega t, e to the power minus at cos omega t. And here L of f means calculating the Laplace transform of all these functions. You will see the complete table coming below. After simulation, when you simulate this, you will see a table like this. So Laplace transform of 1 upon s, Laplace transform of t 1 upon s square, Laplace transform of e to the power minus at 1 upon a plus s, Laplace transform of t square e to the power minus at 1 upon a plus s square, like that, and 2 upon even a plus s, probably like that. For all the functions, Laplace transforms are calculated with the help of the standard Laplace transform equation. Okay, thank you.